Hi, I'm anxious to talk to you today about your brains. One thing we know about humans is they have a lot of limitations. In fact, when we're given a decision to make and we don't have a lot of time to make it, we tend to take shortcuts. So if a problem is really complex, it's got a lot of possible solutions, we don't tend to want to get into the details of try to analyzing it. We want to make kind of a quick snap decision, and that can be an issue at some time. I have here a picture of the brain that was drawn in an encyclopedia in 1883, and of course since then neuroscientists have developed lots better pictures of the brain using MRIs and other types of things, so we kind of know about these different parts of the brain and what their functions are, but we still don't understand why humans have all of these particular biases and other limits to their rationality. So I want to talk about that a little bit today. First, I'm going to give you a little teaser. So this is a question for you to think about while we're talking. Suppose a bat and a ball cost $1.10, but there's a rule that the bat costs $1 more than the ball. So the question I want you to think about is, how much does the ball cost? Now, talking about these cognitive biases, this is like an eye chart that makes it really difficult to tell what's going on here. But in essence, this is all of the researched areas where scientists have found that we have limitations to the way that we think. So for example, some people are, when they're trying to make a decision, they're drawn to details that tend to confirm that decision. They don't tend to pay attention to any of the other implications or other options that might be available. So let's say you're going to buy a new car, and you go to the car lot and you see this beautiful red car, convertible that you've already dreamed of, and somebody starts to mention gas mileage and insurance, and you just don't really hear those types of things. That's an example of a bias where we're looking for confirming evidence to support a decision that we probably have already made. There are other types of implications to this too. Suppose that we have about 10 to 20 different options to choose from. We quickly tend to eliminate them, sometimes on a basis that isn't very logical or rational. Well, cognitive scientists and others have studied the human brain to understand all of these biases, and we'll talk a little bit about how people might overcome them. So what is this thing I'm calling a cognitive bias? It's really a systematic pattern where you're not so rational. And we like to think of ourselves as very rational, but sometimes we create our own rationality and basically describe that as the way the world is. We may construct that view of rationality and build our worlds around it without even realizing that there's other alternative ways to be viewing things. So cognitive biases lead to distortion, inaccurate judgment, and what in general we call irrationality. So how can you overcome cognitive biases? And why are we talking about them in this course? Well, it turns out that in addition to organizations making use of technologies for competitive advantages, individuals can make use of technologies for competitive advantage as well. So technologies may be able to provide certain types of tools and support mechanisms that help us overcome our biases. That's called debiasing. And it's intended to sort of get in the way of our automatic processing. And there's really three general approaches that you might take to do debiasing. One is you change incentives. So maybe you pay people a little bit more to look at all those alternatives that they might not otherwise. Or you can do nudging. You've probably done this with a friend and said, maybe you really ought to think twice about that red convertible that you've been pining for. Also, we can train people to avoid biases and use tools in that training that help them avoid it in the future. So it comes down to the fact that people process information in about two different ways. One is our system one, and that's a very fast, automatic type of decision making, and it's very susceptible to environmental influences. So for example, when you go into the ice cream shop and you want to pick a particular flavor because you're in a line, and you say, well, I think I'll try one or two flavors, or maybe you don't even try one or two, you just go with your own standard. Well, is that the best alternative that you could come up with? Well, sometimes time limits us in that context, so we have to, in that environment, apply System 1 type thinking, and make a decision quickly. System 2 then is more slow and reflective, maybe more applicable when we're buying that car because of the amount that we're investing and spending. So here we want to take into account all the goals that we have, all our intentions, and break things down into the logical components that might help us make that decision. And that can involve building a prototype. So for an example, we may build a prototype out of clay of a building to be able to see its dynamics and visualize what it might look like. We may prototype example systems or landscapes using computer technologies that help us visualize what it might be once we get the home built or the landscape done. Well, that's an example of using a prototype or a model to be able to help us do this more systematically. So System 1, when we use it, we tend to use what's called heuristics. And heuristics, the definition of that is a rule of thumb. And you probably have a bunch of them that you follow. For example, as you drive or bike or walk to work, if there's a disturbance in front of you, you immediately employ some heuristic on how to get around it, or maybe to take a different route along the way, something that you just say, well, this will work out and I can make it happen. Now, heuristics are amazing because our brains have learned those over time, and they make do in circumstances when we don't have all the available information. But in general, building models and prototypes can really help us keep on track. So I want to tell you a little bit more about models. And this again applies to System 2 thinking. A lot of models, we could kind of think of those as black boxes. In a black box, you have some inputs, and then some processing takes place, and there's some output. Our brains are kind of like that. We see something, visualize it. We oftentimes can't explain how we reached a decision because it's kind of a black box to us. Well, when we construct a model, it helps us break down those processes into discrete steps where we look and think about individually each step as part of a whole, but by decomposing it into these sub-steps, our brains can tend to focus more on the issues related to that sub-step and then provide some generality of all those steps into a coherent whole. Most of the time in business, we're using variables, and we may manipulate those variables to be able to determine outcomes. So for example, if you're thinking about doing currency exchange, when should you do it? What time should you do it? What day of the week might be best for you to do it? So you may have some heuristics that you would apply, but it could also help maybe to look at some prior data or some websites where they're predicting what the currency rates might be. So as we decompose the problem into more steps where we might gather more information, we might end up a little bit better on that currency exchange. So in most businesses, people document this type of System 2 thinking and their models and prototypes in a spreadsheet language. And they've really become prolific in business. I think they're almost like a second language of business. We build models in them, we share those models, we make decisions using those models, all constructed inside spreadsheets. Why did these spreadsheets catch on? I think it's because they match the way our brains operate. So for example, we can think of a cell in a spreadsheet as an object, and we can think of another cell and cross-reference those two cells by thinking about the interrelationships between objects. We tend to refer to them as rows and column numbers, which makes sense visually to us, even though we're thinking in terms of discrete steps we might take to build a model for a hard problem. Now we enter numbers into some of the cells. We might put formulas in other cells that calculate things like the current value of an exchange on currency using those numbers. And we're able to modify and play with and evaluate different circumstances as we leverage our model to help us make a better decision. So why are they so popular? Really, I think it's those spatial relationships that are consistent with the way humans define things, and they're pretty forgiving. You can enter some numbers, and as you will learn in this class, and when you develop your own spreadsheets, there's nothing that you can do wrong. You type something in and mess it up, you just kind of erase it and start over. There's always intermediate results for you to review and take in and evaluate whether your way of decomposing the problem is actually making sense. I've seen it in lots of situations where people given the same problem don't even model it the same way, but it's pretty neat because they come up with the same optimal solution to a decision situation. So we all may decompose it differently, and being able to use spreadsheets to help us model in the way we want to makes a huge difference. We can also take the spreadsheets and put colors with them and add different elements, and that enables us to share our ability to build models with others. And so when we have a model that helps us make a decision, we can use the model to explain the results to another person by showing them our spreadsheets. We can let them play with it, especially if it makes sense to them intuitively on how to use it. So a lot of times you hear this referred to as what-if analysis with spreadsheets. You enter a number and say, what if I change this? What will happen? What will be the results? And you can continue to modify a spreadsheet so that you can see different circumstances arise and get a feel for the nature of the whole problem, even though you've broken it down into its subparts.